this first problem sets the stage, first of all. You can see you're working with the array list called list. What kind of array list is it? Well, it holds integer objects, but Java doesn't know that. Why not? Because it doesn't say array list angle bracket is integer. So as far as Java is concerned, there can be any kind of objects, and there's array list, right? And so keeping that in mind as we're looking at the code. But basically, you're going to need a typecast. And the whole point is to come up with which of these options would work in this, to put here. After read the direction, it says, determine which of the following can be used to replace expressions so that the code segment correctly computes the sum of the values. And what is sum? An int. All right? And so, one more thing to keep in mind, as it says, it's bolded here, it says, remember that the dot operator has high, or the member of operator, you can call it, has higher precedence than the typecast operator. Which means sometimes you need parentheses to make the typecast happen when you want it to happen. Okay? Now, we're going to go through these in order. This one's just a complete fail, because what are you getting? An object, some kind of object, and you can't just add any kind of object. Like if this is an int, you put a string here, it would not compile. And so, which one of these is the reason why it fails? Yeah. So go put C here, and so we're done with C. All right. Let's try the next one. Next one, the rest of them all have typecast, which is necessary, but this one, once again, because the parentheses are here, it's forcing the typecast to happen before it calls the get method. Now, but what is a typecast? What is list? An array list. And so, hold on one second. Now, so what I'm saying is, you're trying to typecast the array list to be an int, which doesn't make sense in the first place. So it is a fail. Which of these explains that failure? D. You can't typecast a reference to be a primitive. If you chose B, it looks good, but we're not actually typecasting an integer object. The typecast says it's an int. So it is D, okay? Now, the next one is trying to still typecast the array list as an integer, which is a fail. And now that one's B. Because once again, array list is not an integer. Now, the next one, once again, the typecast applies whatever is given to it, and it's basically, since the dot operator has higher precedence, the get method gets you what's out of the array list, which is an integer object, and then the typecast tells the compiler that it is an integer object. This is good, in other words. It works. Now, is it E, F, or G that explain correctly why it works? Yeah. In fact, hold on. Change colors here, and I would highly recommend like star this, underline it, circle this one, because it did work. Okay, you want to keep track of which ones are successful. Now, one thing I want you to notice is the next one we're looking at. It just has the previous part with parentheses around it. Yes. And so there's what did F get us? An integer object. Yes, it successfully gets an integer object, and the integer class has an int value method, which you don't have to call, but used to you had to call the int value method. So the int value method it unboxes the int, gives you the int, which means this is successful. Once again, so what we're trying to do is get the int and get it added to the sum, right? So I'm saying this one also succeeds, and it may be hard. G's the answer. That is how you call the int value method in this case, because once again, you first have to get the typecast to happen before you call the method on that integer object. So that's how we're going to describe that one. By the way, just for the record, the one above it, I didn't really talk about how F would it look like here. So if I put F here, once again, what did F give us? An integer object. What is sum expected? An int. But Java auto unbox that int. It works. Okay. All right, moving on. Look at now we only have two left. Which of those do you think works? So actually, if you look at the options, first of all, let's talk about the next one. The get is getting an integer object. This has got a little bit of magic here. What I mean is, you say you want to typecast the result of the get as an int. Java assumes it actually is an integer object and calls the int value method for you. Auto unboxes the int, and it works. In other words, the get better would be getting you an integer object, which it is, and then it just changed it into an int, and that is what is passed on. And listen, when I come in here, if I have an int stored here, it just automatically will use the int as the sum. If I put an integer object here, on the other hand, it has to unbox the int first. So I'm just saying, up here where we got an integer object, it worked because of the auto unboxing. Here where we get an int, it just uses the int. It's the same. They both work the same result. The question is, where does it get turned into an int? Here, this is E, by the way. As it says, Java treats the object as an integer object because of the typecast, and then also auto unboxes the integer. Maybe I should say the auto unboxes the int, actually. And so I'm saying the plus equals is given an int to work with here, whereas the plus equals is given an integer object to work with here. Anyway, now this last one, you can see, it's E with parentheses around it, and then we're calling it int value method. But we just established that E produces an int, and ints don't have methods, and so that the answer is A, obviously because it's process elimination. But yeah, you can't call methods on primitives. So now, look at this. The moral of the story is, when people try to do this, they mess it up in various ways. You can see all the ways to mess it up. There's 3 ways that work, but you don't have to know every way it works. You just have to know one way it works. Frankly, I would just circle the 2 nice ways, the shortest ways, and just realize, as long as you have a typecast in there that's going to be an int, you're good. It works. Okay? Okay, keep going. Do the rest of it. All right, number 2. And first of all, I want you to notice number 2, 3, and 4 are almost identical. The difference is number 4 is an if else. Number 2, everything's conditional. In other words, both the recursive call and the print are part of the if statement. Whereas, that's number 3, I mean. Number 2, the recursive call is conditional, but the print will happen every time. Right? So that's the difference. But the recursive calls are the same. So in other words, here, on every case, where our initial input is 2. And so, ideally, you show the work like this. So you list what the method does. And so, in this case, it's going to do the recursive call and then print. And once again, it can't do the print until it does the recursive call. So you need to start over with an input of 1 and show what that does. But once again, it can't print the 1 until it does the next recursive call. And then the last recursive call, once again, this is not true, so it doesn't do any more recursion. It just prints 0, and then it backtracks, and you can follow the arrows. It returns right back to where that call ended, and then it prints a 1. Then it returns back to where that call ended. So, E of 1 was called. When it's done, it returns back here, and then the 2 can be printed. So the answer is A. Look at B. I mean number 3. The exact same list of methods. They're all doing the same thing, except, like I said, on this one, it either does recursion and print, or it does nothing at all. So it's the same until you get to here, and then there's just nothing there with the last call. And so you don't see the 0. And so, what is the answer? E, yeah. And then this last one, it either does the recursive call or prints. And so, once again, all the same method calls. But here, when it gets to the last one, that's the only time it prints. So, you see the 0. And then, once again, everything else was just a recursive call without any print statements. Yeah? Then we get to this.
Oh boy.
Yes, exactly. It is a bit weird, I'll just say. All right, let's go through it. First of all, we create our initial triangle object with the 5, obviously. And then we call the getArea method. And the getArea method is kind of weird for 2 reasons. It returns the area, it does, but it also prints the area. Okay? It actually prints it in 2 different places. Now, we're going to have to kind of keep track of various objects that are made, because that's the other thing. Right here, the getArea method makes a new triangle object. Okay, so here, let me start going through this, and I'm going to show it this way. On a size 5 triangle, and I'm running, and I'll put it this way, I'm running the size 5 triangles getArea method. Okay, that's what I'm doing right now. So if I start this with the width of 5, of course I'm not doing that because the width is not 1. So, but this is the first thing I'm going to do, is make a new triangle with the width 4. And I would recommend writing this down. This is a weird problem. And so I would go through all these steps. And then, okay, I'm going to try to fit this in. So the area of this one is, you know, I'm just going to say it this way. You know, it's a smaller triangle. I'm just going to call it T4. Not proper Java notation, of course. But my smaller triangle, size 4 triangles, dot get area, plus the current width. What is the width of this triangle? 5. We're running the code for a size 5 triangle. So I'm saying that line there is going to produce that. We're not done, of course. This method is going to do 2 more things. It's going to print and return, but we can't do that yet because we just have a recursive call, right? So let's do T4.getArea. So try to squeeze this all in. And we start the getArea method over again. Once again, the width is not 1, so we don't do that. We do this, so we create a new triangle, size 3. And then the area of this triangle is going to be the area of the smaller triangle plus the current width. The current width is 4, right? But once again, we have to do a recursive call, so we're calling the T3 getArea method. That's T3. Just trust me. And we have a new triangle of size 2. And then this one is going to equal that one's getArea. I'm running out of room. Let's see if I can. Plus 3. So T2's getArea plus 3. So we have to start over with and run T2's getArea method. And it's going to create a new triangle size 1. And then its area will be that one's, the T1's area, plus what? Plus 2. Once again, I'm running, I want to highlight it, but anyway, I'm running this code right here, repeat on it. And finally, we have T1. And so if we run this code for T1, then all we do is this, yes? Which means we finally get some output. So somewhere we have a link for output. Write this down. W equals 1, A equals 1 is the first thing being outputted. Okay? So the getArea method here printed that, which I'm not going to show here, and then it returns 1. It returns 1 to where? Well, to where it was called. So right there where it called the getArea method, the answer turned out to be 1. So the area of the smaller triangle is 1, and then 1 plus 2 is 3, I think. Pretty sure. And so we're on back to the T2 level. We just figured out the area was 3, and so now we're going to print what? The width is what right now? 2. Once again, we're on this triangle. Its width is 2. Its area is 3. So go back to your output and print that. The width is 2. The area is 3. And then after printing, what does it do? It returns. Returns what? 3. Sorry, this is messy, but it's better than last week, I'll tell you that much. And so, and once again, come back here, that turns out to be a 3 then. So the area of the size 4, the size 3 triangle turns out to be what? Because 3 plus 3 is 6. And once again, after computing the area, it does these 2 things here. It prints the result and returns the 6. So let's put that on our output. Get the right color. So for the size 3 triangle, the area turned out to be 6. And so once again, this returns a 6 to the previous one. And so that one ends up being, the size 4 triangle ends up having an area of 10. And so size 4 triangle, hold on. I need the color coding right. Had an area of 10. And then that 10 gets returned all the way back to here. was wrong. This turned out to be 10, so the original area was then 15. Alright, so let me put that here. Come back. Now, so the get area method has been printing all of this so far. Now the last time, once again, the last call to get area, this first call to get area, let me go through it again. It created, hold on. I want to redo this. When the size was 5, we didn't do this. We did this. We then computed the area. We just got that. The area turned out to be 15. We just printed it, but then we also returned the 15. Yes? Returned to where? Where was that method? Where was the get area method first called? Back in the main method, right? And so the 15, the final 15, ends up right there. And so you need one more line of output. Final area equals 15. And like I said, it's just, it's weird. You're creating all these objects recursively. Now, more thing I want to explain to you. These numbers that we produced, 1, 3, 6, 10, 15, there's a name for that set of numbers. They're the triangular numbers. Watch. So, if I do 1 and 2, I get a triangle, that triangle, the area is 3. If I add 3 onto that, so now it's 1 plus 2 plus 3, I get 6 for the next triangle number. You add another row of 4, you get the fourth triangle number, which is 10, then add your fifth row, and you're up to 15. So 15 is the fifth triangular number. So anyway, a little math tossed in there. There's also like pentagonal numbers, hexagonal numbers, and whatnot as well. All right, very good.